we're going to learn a few things about tangents. So you're going to need to follow the directions, such as using a straight edge, draw the radius AB, and also draw two lines tangent to the circle. Pause the video, get it drawn, answer the question, what do you notice about the angle created at the point of tangency? And then hit on pause, and we'll kind of go over what is going on and what the theorem is. If you drew the radius and the tangent, you can see that it does look like it forms a right angle. And in fact, it does. So the theorem goes that if a line is tangent to the circle, then it is perpendicular to the radius drawn to the point of tangency. This is going to help us because we can use these right angles to form right triangles, use the Pythagorean theorem, find missing sides. It also works, the converse also works. If you look in your book, this will be theorem 10.9. 10.10 is sort of the reverse of it. It just says if a line is perpendicular to a radius, and they're saying the radius at its endpoint on the circle. So if a line is perpendicular to a radius at its endpoint on the circle, then it's tangent to the circle. So we're going to use this little theorem on the back page. But before we do, we're going to learn one other one. I want you to follow these directions and draw two lines that are tangent to the circle at points F and E. So you're going to line up your ruler and do your best to make a tangent line and then make another. And where the two cross each other, you're going to call that point K and answer the question, what do you notice about FK and EK? So hit pause and see what you think. If you look at KF and KE, they do appear to be congruent. And if you took out a ruler, they'd be pretty close to it, depending on how good you were at drawing your tangent lines. So there's a little theorem that goes with this. And this theorem, in your book, it would be 10.11, in case you want to reference it. It states that if two segments from the same exterior point, that's the huge part, so if two segments from the same exterior point are tangent to a circle, then they are congruent. And this is going to be helpful too in solving for some missing distances. So get this all written down, and we're going to try an example on the back side. Okay, using those two theorems we've just learned, where you have a tangent that's perpendicular to a radius, and two tangents from the same exterior point are congruent, we're going to mark all the right angles in this picture, and we're going to find some measures. And the most important thing is use exact answers. So put that calculator away. All right, so go ahead and start marking where would you find any right angles in this picture. And we're also going to mark that this is 14 and that GH is going to be 7. So take a few moments, and in about 5 seconds, all of these answers are going to reveal themselves. Okay, let's see why the answers come out to be what they are. This is a radius, this is a tangent line, so we have some right angles. if we look at this triangle here with the 7 and the 14, we can find this side because we can use the Pythagorean theorem. When you do that, you're going to get a funny square root. But if you simplify it, you're going to find out that this entire thing here equals 7 root 5. So GI came out to be 7. It's a radius. IL was 14 because the two tangent lines are coming from the same exterior point, so they're congruent. GL, we just said, is 7 root 5. So I'm going to leave you to find ML and bring it to class. Like it says here, ML is equal to this entire thing minus GM, which you know the length of GM. Bring that to class and let's see what you come up with. But we're going to move on. We're going to skip name all the congruent segments. And I want you to take a look at this. Using the figure below, find LC. LC is this little piece. Unlike the problem above, it's not going to come out to something weird with a funny square root. So try this problem. Everything's labeled. It's safe to say that this is a tangent line because we see the right angle. And it's safe to say that this one over here is a tangent line. And so, if you have two tangents from the same exterior point, we can say they're congruent. So that's a great place to stop. I'll see you tomorrow in class.